Hi, Assalamualaikum and good day. Today you are going to learn chapter 2 that is on vectors. These are the objective of today's lesson. Hopefully by the end of this session you should be able to distinguish between a vector and a scalar, understand the definition of a vector and its representation, and able to do the following operation on vectors. Before learn about vector, let's start with a brief introduction on scalar first. Scalar, which is specified by a numerical value, is a quantity with the magnitude alone. One example of a scalar is distance. It tells us how far we are from a fixed point, but not giving us any information on the direction. Other examples on scalar quantity are distance, mass of an object, temperature, area, and volume. As for vector, it has both magnitude and direction. One example of a vector is displacement. It tells us how far we are from a fixed point, and it also tells us our direction relative to that point. There are many physical quantities which are best described as vectors, such as velocity, acceleration, and force. Typically, a vector is illustrated as a directed line segment which can be drawn as an arrow. The length of the arrow represents the magnitude of the vector, and the arrowhead indicates the direction. A vector from an initial point A to a terminal point B is denoted by symbol such as a small bold letter A or capital bold letter AB. In writing, we normally put an arrow on the top of the symbol used to replace the bold typeface. Vector BA denotes the vector from point B to point A. Two vectors AB and CD are said to be equal if they have the same magnitude and the same direction, that is, AB equal to CD. If two vectors AB and CD have the same magnitude but opposite direction, then the one is the negative to the other. That is, AB is equal to negative CD. A vector may also be represented using a coordinate system. In two-dimensional space, a vector from the origin to the point A, denoted by OA, is represented by the coordinate 5, 3, which is equal to 5i plus 3j. In three-dimensional space, a vector from the origin to point A, denoted by OA, is represented by the coordinate 5, 3, 2, which is equal to 5i plus 3j plus 2k. A vector which is started from the origin to a point A is known as a position vector and denoted by OA. For any vector v, there exists a parallel vector of magnitude 1 unit, which is known as a unit vector in the direction of v. A unit vector, denoted by the hat symbol, is found by dividing the given vector by its magnitude. Consider a three-dimensional Cartesian coordinate system with a point P in space, specified by its Cartesian coordinates x, y, z. I, j, k refers to unit vectors in the direction of x-axis, y-axis, and z-axis respectively, and they are called as Cartesian unit vectors. Consider a vector where the initial point is at P and the terminal point is at Q. Here, OP is the position vector of point P relative to the origin, and OQ is the position vector of point Q relative to the origin. To find the vector PQ from the given 2 points, it is equal to PO plus OQ, which can be simplified to OQ minus OP. SOP equal to x1i plus y1j plus z1k and OQ equal to x2i plus y2j plus z2k, PQ is equal to x2 minus x1i plus y2 minus y1j plus z2 minus z1k. We can express the vector PQ as follows, where the Cartesian unit vector I, j, k are not shown. Magnitude of a vector refers to the length of the vector. Magnitude of a vector U is denoted by modulus U and defined by the formula of square root of the sum of all components with the square, that is equal to the square root of U1 square plus U2 square plus so on. Refer to example 1. Let U and V be vectors in three-dimensional space. You need to find the magnitude of U and V. Therefore, magnitude of U is equal to the square root of -1 square plus 4 square plus 3 square, which is equal to square root of 26 units. And magnitude of V is equal to the square root of 1 square plus 0 square plus -2 square, which is equal to square root 5 units. Now that you have the basic idea of what a vector is, next we will look at the operations that can be done with vectors. The first operation is on equality. If two vectors are equal, then the corresponding components should be the same, meaning U1 equal to V1, U2 equal to V2, U3 equal to V3, and so on. To add or subtract two vectors, you need to add or subtract the corresponding elements or components, that is, U plus minus V equal to U1 plus minus V1, U2 plus minus V2, U3 plus minus V3, and so on. Scalar multiplication refers to multiplying a scalar and a vector. If k is a scalar and u is a vector, ku is obtained by multiplying all components in vector u with the scalar k, that is, ku1, ku2, ku3, and so on. Take note that two vectors are parallel if one of them is a scalar multiple of the other vector. Refer to example 2. Given two vectors R and S. If R is equal to S, find P and Q. By equating the corresponding component of both vectors, you will obtain two simultaneous equations, which are P plus 2 equal to Q as the first equation and Q minus 4 equal to negative P as the second equation. Substitute the first equation into the second equation and simplify. You should obtain P equal to 1 and Q equal to 3. Now refer to example 3. Given two vectors V1 and V2 in three-dimensional space with a scalar C equal to 3. Find the following operation. V1 plus V2 is obtained by adding the corresponding component of both vectors, 3 plus 4, -7 plus 5, 1 plus -2, which can be simplified to 7i minus 2j minus k. As for V1 minus V2, it is obtained by subtracting the corresponding component of both vectors, 3 minus 4, -7 minus 5, 1 minus negative 2. Simplify, you will get negative I minus 12j plus 3k. 3v1 is obtained by multiplying each component of vector v1 with scalar 3. You will get 9i minus 21j plus 3k as the answer. To find the magnitude of 3v1, it is equal to the square root of the sum of each component with the square, that is equal to the square root of 9 square plus negative 21 square plus 3 square. Simplify, you will get square root of 531 units as the answer. Proceed with example 4. Given three vectors A, B, and C. You need to find the magnitude of the vector A minus 2B plus 3C, and you need to find a unit vector in the direction of A minus 2B plus 3C. First, find the answer for the vector of A minus 2B plus 3C. 2b and 3c are obtained by multiplying the scalar with all components in the respective vectors. Then, add and subtract the corresponding component accordingly and simplify, you will get 9i minus 25j plus 14k as the answer. To find the magnitude of the vector, it is equal to the square root of 9 square plus negative 25 square plus 14 square, which can be simplified to square root of 902 units. Next, to find the unit vector in the direction of A minus 2B plus 3C, it is obtained by dividing the vector with its magnitude. You will get 9 over square root 902i minus 25 over square root 902j plus 14 over square root 902k. To check your understanding on this lesson, please do the following exercise. In the next lesson, you are going to learn about product on two vectors. So,